Okay. Uh, Last class I had already discussed about object-oriented programming language. So today we will be doing some introduction of Java. Okay. Now see introduction of Java. Now before learning Java, you should know what kind of programming is Java. Java is object-oriented programming language, right? Then after that, who created Java? Like C was created by Dennis Ritchie, right? Like that, Java was created by your James Gosling, Patrick Norton, Ed Frank. Okay, at Sun Microsystem. So see, it was developed. It was developed in 1990. Okay, Java was developed in 1990, which was initially known as Oak. Named as Oak. Oak means tree. Okay, Java was first developed in 1990, which was known as Oak. But later in 1995, it was renamed to Java. Okay, now Java is a place. Now see over here, as I said, Java was developed by James Gosling, Patrick Norton, and your Ed Frank. Okay, in 1990, which was initially known as Oak, but later in 1995 it was renamed to Java. Now, see, Java is basically developed for net-based application. Okay, that means it has got several features. Okay, it has got several features, and those features makes Java very popular. Unlike your Python, unlike your other programming like R programming, okay, Java is still popular because of various features which are provided, right? So now learning about the features, I want to tell to the viewers that there are some students who is from school section and also from college section, right? Now the school section in here, especially if I talk about class 10 and 12, okay, the features have been limited in your books. Okay, whereas if I talk about college students, your features of Java is broad. Okay, so I have got few features. See, these are the features of Java. Actually speaking, these are the features of Java where in class 10 and class 12 the features are very limited, like object oriented, simple, platform independent, bytecode and application is only given in your book. Okay, but for college student you have to remember all these features. Okay, now Java is very popular because one of the reason is it is very simple to code. Unlike a C programming, C, what happens is that in C, if you write int x and if you want to print the value of x, okay, printf, you need to know the format specifier, that is what kind of value is x, you need to know. So modulus d indicates integer value. Okay, so modulus d indicates the integer value where you need to print the value of x now. Okay, so modulus d indicates the integer value, you are printing the value of x. But in Java it is very simple, you don't have to know the format specifier at all. This is not required. If you write int x equals to 10 and directly write system.out.print, okay, system.out.print, and if you write x, it directly outputs the value 10, which is the value of x. Okay, so one of the reason why Java is popular is it is very easy to code. Okay, next is platform independent. See, platform independent basically means now there are various users across the world or across the globe. Okay, some are using Unix, some are using Windows. Various kind of operating system are being used. Okay, you know that the applications that are made for Unix cannot be run under Windows, right? And such as Windows has its own media player, your Unix has its own media player. Whatever the programs Windows Media Player that is played in let's say Microsoft or Windows operating system, that cannot be run. Okay, you cannot install that in Linux or Unix, right? So it is platform dependent. Okay, but whatever the code written in Java, it is platform independent. That means Java is known as platform independent programming language because the code written in Java can run under any CPUs and any operating systems. Okay, it can run under any operating systems. Okay, next is robust. Robust means strong. Okay, strong in a sense, Java is very strong because of its error handling. Error handler is present, and error handler in Java is known as exceptional handlers. So in Java, exceptional handlers, okay, are very strong. There are various exceptional handlers used in Java, which makes Java a very popular. Next, it supports multimedia. Now, Java supports all kind of multimedia plugin device. Okay, that's why Java is also popular in that ways. Next is multi-threading. Now, what does multi-threading means? Multi-threading means running the program concurrently, several programs concurrently. Okay, that means two or more programs can be run at a time, right? So Java has the features of multi-threading, that is also known as threading. Okay, we will do later. Okay, next is your bytecode. Now, what is bytecode? Bytecode is the highly optimized set of instruction which is executed by JVM. Now try to understand this. Whatever you write in Java, that is known as source code. Okay, now that source code gets compiled into bytecode. Okay, and that bytecode gets converted into machine level language by JVM. This is machine code. Now, what is this JVM? This is the interpreter. Now, before learning what is bytecode, what is source code, what is machine code, you must know what is compiler and what is interpreter. Okay. Now, see, compiler and interpreter both are known as translator. Now, let's say somebody is speaking in Chinese. Okay. Now, we are Indians, we speak Hindi or either English or either some other local language. Now, a person who is from China, let's say, is visiting in our place. Now, when we try to interact or when he try to interact, let's say that person does not know any language other than Chinese. We also, let's say, we don't know any other language other than Hindi. Then, how to interact with that Chinese person? There has to be some kind of conversion or interpretation taking between us. Okay, there has to be some interpreter, there has to be some language translator. Okay, there has to be some translator that converts Chinese to Hindi, Hindi to Chinese again. Okay, so some kind of translator is required. So what is the work of translator? Translator converts one language to another language. So over here also, in programming also, as computer understand only the language of machine code, that is in the form of binary language, which will be in the form of zeros and ones. Okay, so computer understand only the language that is 0 and 1. Okay, so see over here, whatever we type A is a language, right? A is the alphabet, characters. So we don't understand, we understand what is A, but computer does not understand what is A. Okay, so some kind of language conversion is required. So A has to be converted into binary code. So the ASCII value of A now comes ASCII. Okay, what does ASCII stands for? American Standard Code for information and interchange. See, ASCII stands for American Standard Code for Information and Interchange. It is a code changer. Consider every student in a class is given a unique number that is known as roll number, right? Let's say 5 students sitting in a class have same name, same title also. Okay, now how to recognize that that particular student is this only? A teacher gives a unique roll number to all that students. Okay, a teacher gives a unique number to that students where a teacher can identify, oh, this roll number belongs to her or this roll number belongs to him, right? Similarly over here, this ASCII also has given, this ASCII also has given a unique number to each and every characters. Okay, so we basically have 256 characters, ASCII characters, of which very important things are capital letter A to Z has the ASCII value of 65 to 90. Okay, whereas small letter a has the ASCII value of 97 to 122. Similarly, when you press 0, it has the ASCII value of 48 to 57. Your space, whatever the space bar that you paste, has the ASCII value of 32. So this ASCII value is very, very important to you. Okay, you need to learn this. You need to memorize the ASCII value of a particular character. Okay, so the ASCII value of A to Z is 65 to 90, small letter a to z is 97 to 122, 0 to 9 is 48 to 57, space is 32. Okay, you have to know this ASCII code. Now see, I was talking about A. Now whatever you press from a computer A, computer does not understand anything. Okay, as I said, computer does not understand anything. So the ASCII value of A, assembler converts the ASCII value of A into its ASCII code, that is 65. Still computer does not understand what is 65. So what is the binary conversion of ASCII value 65? 2 3s are 6, 2 2s are 4, remainder is 1, 2 16s are 32, remainder 0, 2 8s are 16, remainder 0, okay, 2 4s are 8, remainder 0, 2 2s are 4, remainder 0, 2 1s are 2, remainder 0. So the ASCII value of A, that is 65, is read by the computer as 1000001. When you press A, computer understand that user has pressed the value this. Okay, now see, one kind of language translator is being translated. This is known as high level language. That is the language that is understandable only by the human beings are known as the high level language, and 1000001 is the binary language. This is the language which is understandable only by the computers. Okay, so see, whatever we type in computer, that has to be converted into binary form. So because computer understand only in binary forms and we understand only in human language, right? That is the high level language. So some kind of translator is required, okay, so that we can interact with the computers, right? So over here, translator are used to convert from one language to another language, right? Now see, I was talking about two translator which are compiler. Okay, this is C. Okay, compiler. I was talking about compiler and interpreter. Compiler and interpreter. Now what is compiler and what is interpreter? It is very important that you have to know, especially for the college student. Now compiler basically is one kind of language translator that converts high level language into machine code. Your interpreter also does that, right? So it converts one language to another language. Now compiler, let's consider this is the code that you have written. compiler compiles all the source code at once. Okay, so compiler, it converts all at once. Okay, whereas interpreter, first of all, it checks this line. Okay, it try to convert this line. If there are error found over here, unless and until you will not rectify this error, next line will not be compiled or will not be interpreted. Okay, first of all, if there is any error, it will report that error, and if it is successfully interpreted, then it goes to next statement. It tried to interpret this. Okay, like that. That means interpreter, it converts one at a time, which means compiler is very fast. It is very fast and efficient, whereas interpreter is converting line by line, which means it is taking more time, right? So it is very slow compared to compiler, as it is converting the code one at a time. So it is taking time, which means it is slow. Okay, number 3, as you can see, the compiler is converting the entire code. So if there are any errors during the compile time, it reports all the errors. Okay, so it reports all the errors. Over here, interpreter, as it is converting line by line, so the errors are reported one at a time. Okay, it report the error one at a time. So see over here, compiler and interpreter, both are translators that translate one language to another language, where compiler, it converts all at once, whereas interpreter, it converts one at a time. Compiler, it is very fast and efficient. Interpreter, it is very slow compared to compiler. Compiler, it reports all the errors. If there exists any error, interpreter reports the error one at a time. Now, why I discuss about compiler and interpreter is that because Java uses both interpreter as well as compiler. We are talking about C or C++, both of these programming only uses compiler. Okay, they uses compiler. Okay, whereas Java uses both. That is one of the difference between C and C++ also. C++ and Java. Okay, C++ and C both uses compiler. Java uses interpreter as well as compiler. Okay, now whatever you write, that is known as source code. Okay, now what does your source code will be first compiled by the compiler into bytecode. Okay, the code that you have typed will be compiled, will be converted into bytecode using compiler, and that bytecode will be converted to machine code by using JVM. Now what is JVM? JVM is the interpreter. It is also language translator, right? Now this interpreter, that is JVM, stands for Java Virtual Machine. Java Virtual Machine. What does it do then? This JVM converts the bytecode into machine code using the interpreter, that is JVM. Okay. Now see over here. Here, once the bytecode is converted into machine code, okay, whichever the machine you have got, whether it be Pentium 4, whether it be other programming, other, let's say AMD Athlon, okay, or let's say other processors that you are using, okay, other operating system, let's say other operating system that you are using, OS, that is either you are using Linux, either you are using Linux, Unix, or either you are using Windows, doesn't matter. Okay, whatever it is understandable by your system, it gets converted into that machine code. Okay, now see what is bytecode. So bytecode is highly optimized set of instruction which is executed by JVM. Okay, so see, once it is converted into bytecode, it turns the code into .class file. Okay, it turns into .class file which can be executed into any form. Okay, which can be executed into any form by using JVM. Okay, that is any operating system. Okay, next we have got is architecture neutral programming language. Java is also called architecture neutral programming language. Now what does architecture neutral programming language means? Let's say in C, basically, okay, for 16-bit, if you write int x, it takes 2 bytes of memory location in C. I am talking about C programming language. Okay, whereas in Java, if you write int x equals to 4 bytes, if you declare an integer variable, okay, this is C and this is Java, same variable C. If you create in C int x, it takes 2 bytes, whereas if you create a variable of integer type in Java, it takes 4 bytes. Now see over here, that means it is particularly in C, it is particularly dependent upon your compiler. Which compiler you are using, 16-bit, 32-bit, okay, 64-bit, okay, it is usually 16 to 32 bits. When you are using 16-bit, it takes 2 bytes, and same when you are creating in 32-bit processor, okay, then 32-bit operating system, it takes 4 bytes of memory location in C. I am talking about in C. Okay, same variable int x in 16-bit, it takes 2 bytes, whereas in your 32 bits, it takes 4 bytes of memory location. But in Java, that does not happen. It is fixed, it is rigid. Okay, every time when you write int x, it is always reserved 4 bytes of memory in your computer. Okay, from your computer. That means architecture neutral means wherever you take that variable or wherever you take that value, that remains fixed. That is, it is not operating system specific. Another thing is that architecture neutral programming language means the code can be embedded in any hardware devices. Okay, the code can be embedded in any hardware devices. Now as it runs, as the code, it runs under any operating system and under any CPUs. That means architecture programming language also can be considered as WORA, W-O-R-A. Write once, run anywhere. Okay. Now next thing we have got is applet and application. Now Java is popular not because of application. Application in a sense, it is also known as standalone program. Like unlike C, see over here, this is a C program that you have written at home. Let's say you have brought that program in a pen drive and put that program in your college, okay, in your college computer, and try to compile and run this. Try to run the same program, it will not be running. Why? Because C is a compiler. C requires a compiler installed wherever you want to run the program. It needs the compiler. Okay, the compiler is needed, or you can say software is needed, right? But Java, in the case of Java, what happens is that when you compile the code, okay, if you bring the code and put it in any system, then the file can be executed. Okay, why? Only because there are two types of program that can be written in Java. One is standalone, another one is applet. Okay, standalone means it is similar to the program written in C. That means it also requires software. It also requires a software. It also requires a compiler. system wherever you want to run the program written in Java has to have a software installed in that computer. That is only in the case of application. Okay, but so Java is not popular because of application. Java is popular because of applet. Now, what is applet then? Applet is a tiny Java program which executes the file. It is a tiny Java program which will be executed the file, okay, using the web browser. Now every device nowadays have a web browser. Your phone has a web browser, right? Your laptop has a web browser. Now wherever you go, your computer has a web browser. No, web browser is already there, right? So applet needs only the web browser to execute the file. Therefore, Java is not popular because of application. It is popular because of the applet program, right? Last thing I have missed over here, the features, okay, is the portability. Okay, the feature of portability over here, Java is portable, which means, see over here, now portable means easy to carry, right? Easy to carry wherever you go. Now, Java as the code is totally web-based applications. Okay, it requires a web browser to execute the applet file. So what happens is that in all the operating system, it is in all the operating system where you talk about Linux, you talk about Unix, you talk about Windows, all of them will be having a web browser. Okay, all of them will be having a web browser. So it is not a platform dependent. Okay, so portability, Java is portable because the Java file can be easily executable. Okay, it can be easily executable. Okay, so see over here, today's class, what we have learned was that in introduction, what we have learned, Java was developed in 1990 by James Gosling, Patrick Norton, and Ed Frank, which was known as Oak. But later in 1995, it was renamed to Java. Now, Java, unlike other programming languages, as I said, it is very much popular because of various features. Okay. Now, its features are simple to code, platform independent, robust, supports multimedia, multi-threading, bytecode, architecture neutral, applet and application, and portability. Now, these are the features of Java. Okay. Then after that, we have done compiler, interpreter. These compiler and interpreter are known as language translator that translate one language to another. Now, when we talk about language translator, you must know what is compiler and what is interpreter. Compiler, it converts all at once. It converts all the code at once, whereas interpreter, it converts the code one at a time. So, compiler is very fast and efficient, whereas interpreter, it is very slow compared to compiler. Next, see, if there are any errors in a compiler, it reports all the errors. Okay, but in interpreter, it reports the error one at a time. Okay, then we have done, see, whatever you have written the code in Java, that is known as source code, that will be compiled to bytecode, and the bytecode is highly optimized set of instruction which is executed by JVM. Now what is JVM? JVM is an interpreter which converts bytecode to